I'm here with Matt Golombek from the Jet Propulsion Lab at Caltech. You are currently the project scientist with NASA's Mars Exploration Rover mission. Can you tell me a bit more about your role and what the aim of the mission is?
It's a rover, it's a geological explorer, and its role is to find an aqueous habitat that could have been a place where life could have gotten a start.
Right, and you've been involved in successfully selecting every landing site on Mars, since the modern era. So what are some of the learnings that you found from doing that?
So the most important thing is the site has to be safe, and it has to meet what we call the engineering constraints. So every spacecraft has constraints about where it can exist and land on the surface. Solar power would mean you need to be near the equator. You probably want a low elevation, so you have as much atmosphere as you can to slow yourself down. You use the atmosphere to slow yourself down. And of course, you don't want any rocks or steep scarps in the ellipse where you land. And the ellipses can be quite large, 100 kilometers for some of these. And obviously, if you don't land safely, you don't get any science.
Yeah, what's been some of the most challenging terrain that you've had to come across?
So certainly the most challenging has been MSL, the Curiosity rover, because it lands in an extremely small space, and we wanted to get to material that was outside the ellipse. So the material of highest interest was not in the ellipse. It's what we call a go-to landing site. So now you not only have to certify that the site is safe for landing, but you have to be sure that there's a path that you can drive from that place to where you want to go.
Absolutely. And so what is the geology like on Mars?
It's mostly basalt, but that's the composition. But there are sandstones and conglomerates and all sorts of, just like any geology anywhere on the Earth, except it's dominantly basalt based. So we have basalt sandstones and conglomerates, and we have evaporites that have very different composition because they're on Mars in an acid-rich environment than here on Earth. So it's just as intricate and detailed, and it's just like geology anywhere, except you're on Mars.
Except you're on Mars. So, saying that, what are some of the issues you've had to contend with doing geology on Mars?
So you have a proxy, which is not quite the same as having a human there. And the biggest difficulty is that your input-output device has this long time lag. There's a 20-minute one-way light time delay, so you can't joystick the rover in any way or form. At the end of the day, it sends back the information it's acquired during that sol, and you're in a new place, a new universe. You've never seen that before, and you have to make decisions.
How does that impact the research then?
In a great way. So the rover has specific instruments. It has cameras. So the Mars Exploration Rover is it's as close to a geologist as we've ever sent to another planet. And we have things that we don't carry out in the field, which are spectrometers that tell us the elemental composition and the iron mineralogy of the materials.
So for students who are interested in extraterrestrial geology, what are some of the skills that you think they need to develop to be able to do what it is you do?
So if you work on Mars, you're what we call, you're a Martian. I'm a Martian, okay? Everything I do is on Mars, and there's this incredible data set that is probably second only to the Earth, and you must become familiar with those. And then it really helps to have a basic geologic background. Can you identify basic geologic features in the field, just as you would here on Earth, and try to interpret the kind of rocks and how they got there?
And it sounds like maybe some patience would be good too.
Yes, you have these long coffee breaks, right?
Yeah. Well, thank you so much for being with us today, Matt. Very interested in hearing the rest of your presentation.
Great, thanks.